A common problem in chemistry is sort of dilution problems. You're starting out with a more concentrated solution and then diluting it down to a desired concentration, or trying to figure out what the volume would be in order to do that dilution. Let's look at a couple of these, but first let's review the kind of theory behind solving these problems. So concentration is typically measured in moles per liter, or molarity. And so if we now have the molarity times the volume, if it's in moles per liter, that's going to give us moles. And so if we take now the initial molarity and the initial molarity and the initial volume, we're going to get the number of moles that are there. If you do a dilution problem, those moles are not going to change. And so it means that we can now take the new molarity and the new volume, and we have to have the same number of moles. If we come now and equate these, and so we get a relationship that looks like this. This now is a very useful relationship because it means that we can take the initial molarity and the initial volume, and we know that has to equal to the molarity of the diluted solution times its volume, because the moles here have to equal the moles here. We're not changing the number of moles. Sort of like in a swimming pool, you can start out with 5 people in a wading pool, and it's more concentrated. If you blow a whistle and put them all in an Olympic swimming pool, you still have 5 people, but the pool is larger and it's more dilute. So this is the useful relationship: molarity initial times volume initial is going to equal to the molarity final times the volume final. So this sets it up. As long as you know any 3 of these variables, you can get the fourth one very easily. Let's look at a couple of questions or problems. And so let's start with this one. And so we're actually asked to find the molarity, and you start out with 75 milliliters of a 4 molar aqueous solution of potassium chloride, and you dilute it to a final volume of 500 milliliters. Well, we know each time we're going to have to you have to use this relationship right here, so we'll bring that in. Here we're looking for the molarity, the final molarity, so this is what we want. If we come now and rearrange that, it means we're really using this relationship right here. Now we just have to come in and add the right things. We've got now the initial volume here, the initial molarity here, the final volume here, and so that means we have it set up very nicely like this. And so there's nothing more to do than to just do the math, plug that in. And when you plug that in, you will find that I think it'll come into about 0.6 molar. So go ahead and do that. Convince yourself that this works. All right, let's try a variation on this. Here we want the final volume. We're given then, this is initial concentration. This is the initial, this is what we want for the final concentration, and we're making that concentration starting out with this more concentrated hydrochloric acid solution, but we're only going to use 20 mils of it. So again, we would start out with the M1 times V1 is equal to M2 times V2. In this case, we're then looking for the volume, the final volume. So if we rearrange that one, this is going to be the relationship that we need. Again, if we come now and look at it, we're going to end up taking the, this is now our final molarity. This is now our initial volume. This is our initial concentration. That means that we're going to end up with this relationship right here when we put all the numbers in, and that should give us something about 8/800ths of a liter, or 80 milliliters for this one. So you can again do the math. Why don't you pause the video and go ahead and try these last two right here. Again, this is one that is looking for molarity, and this one final volume, so they're parallel problems. And then we'll come back and look at the doing the math on those. So pause the video for a second. Okay, so I'm hoping you're back and you came back and looked at it, that this relationship right here would work for this problem. Again, we've got then, this is the final molarity right here. This is our final volume. So this final volume right here is the 2 liters. This is the initial molarity. This is the initial volume right here. And so if you go ahead and do the math, you should end up with about 0.75 molar. Okay, and let's look now at the last one. Hope again you came into this relationship right here. If we looked at it again, we're starting that this is the concentration we want to prepare. This is how much mils of this initial concentration, and so it'll allow us to get that volume right there in making that 1 molar solution from this 1 molar solution from this 12 molar solution. And so that one right there should come out to be something on the order of, I'm not sure, but you can calculate that. It's not too bad. So it'll be about a quarter. I think it's, well, yeah, I worked it out once and I can't remember what it is. But you can do that.